come to a quick video that is talking you through the three main types of factorisation we have to look out for and the order in which we look for them. Now, the reason the order is important is if you look for these out of order, you're going to make the question much more difficult for yourself if you do have to apply more than one of them. But we'll get to an example of that towards the end. The first type of factorisation we are going to be looking at is what we call highest common factor. So if you go looking for extra YouTube videos on this, you're going to type in factorising using the highest common factor. Now what this means is, for example, we have the numbers 2 and 8. Now the highest common factor here, HCF, is 2, because 2 fits into both 2 and 8. What if we had the highest common factor of 10 and 25? So you look at what times tables the 10 is in, so you're going in the 1, the 2, the 5, the 10 times table. You look at 25, it's in the 1, the 5, and 25 times table. So the highest number, the highest times table that has both of those values in it is the 5. So the highest common factor is 5. Now, how does this apply to factorisation? So factorisation is when you're given an expression and you're trying to put brackets in. So at National 5, what you're expected to do is not just factorise numbers out, you also have to be able to factorise letters. And this is an example of where you'd have to factorise the letters as well. You first look at your numbers. Now, 2 and 3, what's the biggest times table they're both in? The 1 times table. We ignore the 1 times table because it doesn't make a difference in algebra. Timesing by 1, not important. So we're left to look at the x and the x squared. Now, because they both contain 1x, the x goes to the outside of the bracket. Looking at 2 and 3, so x times what gives you 2x? X times 2 plus x times what gives you 3x squared, so plus 3x, and you have factorised. Let's look at another one. What if we have 4xy squared plus 6x squared y? So we go from left to right. We're looking first at the numbers. What times table has both 4 and 6 in it? So the answer is the 2 times table. That is our highest common factor of our numbers. Now they both contain 1x and they both contain 1y. So what times 2 gives you 4? 2. What times x gives you x? 1. We don't write that down. And what times y gives you y squared? Y. Plus, what times 2 gives you 6? 3. What times x gives you x squared? X. And what times y gives you y? That's just 1, so we don't write it. And you have factorised. Last example here. What if we have y cubed take away y squared? Well, there's no numbers, so we get to ignore those. We have y's. Now, this is important. How many y's are there in each? The first one we have y times y times y, 3 of them. The second term we have y squared, so there's 2 of them. The biggest amount that's in both is 2. So it's y squared on the outside, rather than just x or just y as we've seen above. Now, y squared times what gives you y cubed? Y. And then y squared times what gives you minus y squared? we're going to have to times it by -1. So this is factorising using the highest common factor. You go through numbers, letters in turn to see what is in both of your terms. Once you've done that and you've got that expression at the front, you then fill in your bracket with your missing multiple that would make the big term on the outside. The second type of factorisation we are going to be looking at is what we call the difference of two squares. Now, again, that means that if you are needing more examples of this, you go to YouTube and you type in difference of two squares and up will come hundreds and hundreds of videos. What is the difference of two squares? Quite literally, it is the difference between two squared terms. So, if I had x squared, and remember finding the difference of two things means take away y squared. That would be the difference of two squares. Now there's a really cool trick that we can use to factorise these. Both of your brackets are going to have an x term. Both of your brackets are going to have a y term. And in between, one is going to be positive and one is going to be negative. So what we've done here is we've square rooted the x squared, filled in our bracket. We've square rooted the y squared, filled in the bracket, and we've made one bracket positive, one bracket negative. Now to check this works, let's multiply it out. X squared plus yx, take away xy, take away y squared. Now remember, it doesn't matter the order you write these in, so they are both the same and they're going to equal 0. Because you're going to add it on and take it away. And that leaves you with your x squared minus y squared. Okay? So, that's the difference of two squares. You're probably not going to get an example that looks like that. What you're going to end up with is something, say, 4y squared take away 9. So you see that you've got two things that are squared. The 4, the 9 squared, the y squared, squared. You do your double brackets. You look at the 4y squared. So over at the side, the square root of 4y squared, square root of 4, 2, square root of y squared, y. And you fill in your bracket. Then over at the side, what's the square root of 9? 3. So we fill in the bracket, one positive, one negative. Let's do another example. Let's have f squared take away 81, in some ways an easier example. So what is the square root of f squared? Well, that's just f. Fill in your bracket. What was the square root of 81? 9. Fill in your bracket, plus, minus. It is important that whatever's in front over here is in front in the brackets over here. Okay, the order is important there. Now, the last type of factorisation we have is factorising trinomials. There are lots of different methods for this, and that's where part of the issue comes in, finding videos online, in that they will all use a different method. But what's great about that is it means if this method isn't making sense to you, you can go find another example online and perhaps that method will work for you better. But let's look at an example like x squared plus 5x plus 4. Now, what's really important is that we find out what A, B, and C are. A is the number in front of x squared, so that's the invisible 1. B is the number in front of x, and C is whatever's hanging on at the end there. We then take A, B, and C, and we create what I call an X factor cross at the side. On the top is A times C, on the bottom is B. So A times C, 1 times 4, 4, and 5. And what you have to do is find two numbers that multiply to give you positive 4, but add to give you 5. So what are our options for multiplying to give you 4? You've got 1 and 4, 2 and 2. Now when you add those, top one, tick, we've got 5. Bottom one, nah, that only gives you 4. So it doesn't work. So we know we are using the top pair. Now you filled in this cross, you found 1, you found 4. Because the number at the front here was 1, because A was equal to 1, you get to go straight ahead and create your double brackets. So we are going to have X plus 1 and X plus 4. Equally, if you'd put those the other way around, completely fine. Okay? There is no issue with the order of your brackets there. So let's look at another example. Let's look at one which involves negatives. So let's have x squared take away, oh, apologies. So we'll still have plus 4, but we're going to have take away 5x in the middle there. So it's a really similar equation, and you might be starting to think, well, probably quite a lot of the method's going to be the same there. And you'd be right. We take A equals 1, B equals, and we have to be careful, minus 5. It's not just the 5. And C equals 4. We make our cross. So A times C, still going to be 4. B, though, is going to be minus 5. And how does this affect us finding our numbers? Well, what multiplies to give you 4? You've still got 1 and 4. You've still got 2 and 2. But if I add those together, I'm always going to end up with positive numbers. We're going to have to go to the flip side. What also multiplies to give you a positive number? And the answer is 2 negatives. So we've got negative times a negative. That would give you positive 4. But minus 1 take away 4 would give you minus 5. 2 take away 2, that gives you minus 4. So that one doesn't work, that one does. Our two factors are minus 1, minus 1, minus 4. Last example, let's do A equals f squared, take away f, take away 2. Okay? We go through, well, A equals 1, B equals minus 1, C equals minus 2. We create our cross. A times C, B, that's minus 2, that's minus 1. What can we get that would multiply to give us minus 2? Now again, we're in that strange situation where we've got a negative in there that we didn't. So, what multiplies to give you negative 2? So you could have 1 times 2 gives you the 2. And for it to be negative, we need one of those to be negative. So we're either going to have 1 times minus 2 or minus 1 times positive 2. To check which one it is, remember we are adding these together. So what's 1, or we're combining them together. So what's 1 take away 2, minus 1, what's minus 1 plus 2? That's going to give us positive 1. So which of these is correct? The top. So there are our factors. And f plus 1, f minus 2. Done. Lastly, we're going to be having a look at a situation where more than one factorisation needs to be applied. And the example we're going to look at is this one here. Now, when you first look at this, have a glance through what sticks out to you. Well, there's not 3 pieces to it, so no, we're not doing that. Imagine what jumped out at you was the fact you've got the difference of 2 squares. Okay? And you decided you were going to factorise using the difference of 2 squares. Well, we're going to have the square root of 4x squared, and we're going to have the square root of 16, and one's going to be positive and one's going to be negative. But there's an issue here. When we look at those brackets, they actually can be factorised further. 2x plus 4, 2x, take away 4. Each of those brackets has a factor of 2. So if we'd done it this way, we'd then have to take out a factor of 2 from each bracket. And then, once we'd done that, we'd have to collect together the 2 times the 2 to get 4 at the front. And it gets complicated, it gets a bit messy, it's not pleasant. Now, the alternative. I said right at the beginning, the order we look for these things is important. So if I go back up here and I have a look, the first thing I look for is highest common factor. Now, 4, 16, are they both in the same times table? Yes, they are both in the 4 times table. But we've not got an x squared in each term, or an x, so we just take out the 4. We then look at what is inside that bracket, the same as we did on the other side of that squiggly line. But this time, what's inside that bracket, we are looking for either difference of 2 squares, tick, we've got that. So, square root of the x squared, square root of the 4, positive, minus. Very lastly, you are looking at those brackets. Is there anything in common that could then be factorised out? No. Do we still have a difference of 2 squares? No. Do we have a trinomial in there? No. So we are done. If you do it using the method on the left, you're going to run into problems. If you do it using the method on the right, everything should fall into place much quicker and efficiently.